Okay, so since I've started on the Tesla Torch flashlights, I've had another idea bounce around my head, and it goes back to the Nathan Stubblefield coils. And I've been really busy, so I haven't had much time to try this out, but I've decided to start on a prototype for it. Now, if you followed my YouTube channel for any length of time, in the past I built quite a few Nathan Stubblefield coils, and they were very interesting, but they were very difficult to build. It was hard to source the cotton-covered wire, etc. So since getting into 3D printing, I realized that I could 3D print a tube that had spacing and everything laid out right into the tube to create a Nathan Stubblefield type coil, which is what I have here. Now, I just want to show an application for this for flashlights. This coil right now is in a dry, non-active hibernation state. And it could sit in a shelf or an emergency box in this state, in a permanent hibernation state. Now you activate it by putting it in the water. So what I've got here is I've got the coil set up to this little DC electric motor. Now I'm going to activate it by putting it in the water, and now it's in the active state. So this motor is running along, and it's going to stay active until the coil dries out.
Alright, well let's race through the build process here. Let's start with the 1/4" copper foil tape. There's a 1/4" groove in the 3D print, and we basically inset the tape in that groove top to bottom. The next step will be to attach a small copper wire to the copper foil to give us a positive connection. There's a hole in the 3D print you can insert it through. Bend one end of the magnesium ribbon over in an L, insert it through one of the holes, wrap it around, and bend the other end in. You can then take a screw to hold that magnesium ribbon down. Put down one nut, followed by another, and between those two nuts, attach another copper wire, forming a negative connection. You'll need to build 3 of these tube cells. Connect them end to end in series, so connect the magnesium ribbon from one to the copper foil on the next. Glue these 3 tube cells together, and that will form the handle for the flashlight. Take the loose wire connected to the copper foil at the bottom of the light and run it up through the inside of the flashlight handle. This will give you a positive and negative connection at the top of the light. Now let's hook up the LED. Take the positive wire, that's the one that comes from the copper foil, and connect it to the long leg on a white LED. That's the positive. Take the wire coming from the magnesium ribbon, which is your negative, and connect it to the short leg on the white LED. Next we'll add a reflector, and that finishes up this first concept build.
Alright, so the concept seems to work great. You dip it in the water, you get bright, usable light, you remove it from the water, and it starts to dry out and go into its hibernation mode. So at this point I just need to get a sheath material. It'll probably be plastic, but it will have holes wide enough to hold water, and yet if you shake it and leave it on a shelf, it should dry out in 5 to 10 minutes. And depending on that material, we could even give this a runtime of half an hour or longer, just depending on the material you use for your sheath. So that'll come up in part 2, but for part 1, this is the basic concept for the Stubblefield flashlight. So what I'm going to do is I'm going to take the light and lower it into the water, and that will activate it. Right now it's in a hibernation state. So I'm lowering the light into the water. And you can see the light's now activated. You can see it's on. Go ahead and flip off the light there, buddy. And now you can see that we've got light. We've got usable light here. And let me show you what I mean. Here, come hold the flashlight, buddy. Always good to have a helper. And yeah, let's just flip into this book. I mean, you can see that this is functional light. And for a light that can be, in a dry hibernation mode state, and to be activated and used like this, I'm quite impressed. And really look forward to improving this light even more. And definitely, whether or not this light is waterproof or not is completely irrelevant as you dip it in water to activate it. So anyway, very, very happy with this. Okay, I just want to point out one other thing. This flashlight used very, very little of this magnesium ribbon. You can get this magnesium ribbon for under $5 a roll last I checked. I'll put links to all the parts at laserhacker.com, but it is important to realize that this has used very little of this ribbon and very little of this copper foil tape. So it's really neat that it can use such a small amount of materials and get something this functional. So anyway, I'm quite impressed. I will definitely continue to improve this prototype. Watch out for part 2 to this video showing the final build.